Kia ora everybody. Today I'm going to teach you how you can use Arcade to calculate and display population data as population density, all within the ArcGIS Online Map Viewer web application. To get started, I have added a layer to my map published by Land Information New Zealand called New Zealand Suburbs and Localities. Opening the table for this layer, I can see that this layer contains a population estimate field, which will be our population data, as well as a shape area field, which we can use to calculate population density. Population density is typically reported as the number of people per square kilometre, whilst the shape area field is in metres squared. Luckily, we can also use Arcade to calculate a conversion for this field to use in our population density calculation. Let's say I'm only interested in the population density of suburbs in the Wellington City area. I will first use the filter tool to only show features where the territorial authority is Wellington City. And now I'll zoom into the Wellington area on the map. Now I am ready to calculate population density. Because I want to display my calculation on my map, I will navigate to the Styles tab, where I can configure how my data is displayed and symbolised. I want to apply an Arcade expression to calculate population density, so I'll select the expression option and go ahead and name my expression population density. Population density is a function of population divided by area. So first, I'll convert my area into kilometres squared in order to display this population density as the number of people per square kilometre. The variable function is able to store data values from calculations, so I will use this for my area conversion. I call the variable function using the keyword var and give it a name. Let's call this one area. Metres squared are divided by 1 million to convert to kilometres squared, so my var is a function of the area field divided by 1 million. Now I can use this variable in my population density calculation. To do this, I simply call the population estimate field using the feature function and divide this by my area variable. If I press run, it gives a number output. This lets me know that my expression is working. Now we can visualize our population density calculation. Map Viewer automatically detects the best style for your data, the Counts and Amounts color option. I will customize my map to use the Red 3 color ramp. It would also make sense to display population density in the pop-ups for my map. In the pop-ups pane, I will create another attribute expression using Arcade. This one will be very similar to our last one with a few key differences. I will also name this expression population density. Just like last time, I will begin by creating a variable which converts the area field from metres squared to kilometres squared. After this, I'll create another variable, this one for my population density calculation. Again, this will be done in exactly the same way as last time, by calling my population estimate field and dividing it by my area variable. Finally, I ask the expression to return the results of my population density variable. However, I call the round function to round the value of this population density calculation to 1 decimal place. I do this so that the results of my population density calculation will be neat and easy to read in the pop-ups in my map. Next, I'll remove the fieldless element from my pop-up because in this case, I want to add a text element in order to make the results of my population density expression incredibly easy to read. So I'm just writing here a short sentence in order to contextualize the results of my population density expression. So here I'm writing that the suburb name has a population density of insert number here, people per square kilometre. And just to make it visually appealing, I am bolding the two variables. And that's it! So, in only a couple minutes, you too can use Arcade to calculate and display population density using just 2 fields within the ArcGIS Online Map Viewer.